So hi again. This time we'll do the same thing. So I think I'll start with the medium questions. Hopefully, okay. In an alien language, surprisingly, they use English or possibly in Colorado. Someone uses English or lexicographically. Okay. So from what I understand is like so basically what he's given in is so the ABCD are arranged in a different order. So let's say in this example H is considered as the new A. Okay, so so one thing we surely need is like we need a value array where we store priority values. So priority values is nothing but in this case H's value is 0, L's value is 1, A's value is 2 and so on. So once we have the priority order, we have to ensure that the strings are sorted. For just checking if the strings are sorted, we just need off and time complexity because let's just say 1 2 3 4 5 6. I'll go from left to right. So for every I should be less than I plus 1. So what we need is a value which returns bool. Let's just say function Greek, and it contains string A, string B, and okay, just let me check. Okay, good. Yeah. It contains string A, string B, and vector, and let's call it priority. So yeah, let's pass it by value. Also, one important thing is always pass this vectors by value. In this case it doesn't matter because there is no recursion involved. But when recursion is involved, when you pass it using address, the storage space will be reduced by a lot. And okay, so yeah, so one thing we need to consider is we need to uh, ensure that A and B are of same length. We need to ensure that we are handling the case where A and B are of different lengths. All right, so I think this is here. So the first three characters match and the second is according to the left, because L greater than 5 is defined as blank, which is less than any other character. So yeah, so basically shortest order wins exactly. So len A is equal to A dot length, and len B is equal to B dot length. So hopefully you guys understand it, and int len is equal to min of len A comma len B. So what I am currently doing is if len B is less than len A, right? So we can only compare until length len B, right? So as long as they both have the common until the shorter one is exhausted, I'll keep comparing it. So in my comparisons, if I encounter a position where one character has a lesser priority than the other, then I'll return true or false based on that. But if my minimum common length is exhausted, and then I and then even then all the characters I encountered are equal, then the lesser length one will be the smaller one. So accordingly I'll return true or false. So in this, let's assume that Crick is trying to prove a less than or equal to b. So here equal to is also important. I'll get to the case where we have equal to. So for now I less than len plus plus. So if I dot I, okay, priority, okay, I really need to stop giving large names to variables. Minus a, okay, priority of a is, you know, greater than b, priority of I minus a, return false. So if also we need to consider the case where a is less than b, right? Because let's say here for example, right, d is less than l, so that's already true. Now we can't compare the fifth one with d here, because here the fifth, like the fourth is already we already got a winner by the time we reach the fourth position, right? We don't need to go to the fifth position as such. So now here which we want is required. So this for loop will go, this return statements will go untouched if and only if all the characters we encountered are equal. And now given that all we encountered are equal, we assume that let's just say return. So for it to be true, length of a should be less than, should be greater than length of b. Okay, so this pretty much guarantees what we want. Okay, now we just have to construct the priority. So I think yeah, order length is always 26, so that's one relief. Priority dot I, no, order dot I minus capital A is equal to I. So we can keep I plus 1, but it doesn't make a difference. It doesn't make any difference, right? So for uh, int I is equal to 0, I less than words dot size minus 1, I plus plus. Here the reason why I kept words dot size minus 1 is like we are comparing I with I plus 1, right? Since the last element in length minus 1, we need up to length minus 2, because length minus 2 and length minus 1 will be considered. Okay, if click, so words dot I is obviously a, words dot I plus 1 is b, and then priority, right? 3 priority. If okay, see, the thing is, if it's true we should continue, if it's not true we should return false, and then return true. Oh, hopefully this is done. Okay, let's just dry run through it once, you know, because from the last video I noticed I keep making compiling mistakes. So let's dry run through it. So bool click, I pass a and b with the priority, so I find out the lengths of a and b, and I find out the minimum common length. So I iterate through the minimum common length, and I see the priority. If priority of a, so the priority should be less, right? Yeah, the priority should be less. If a greater than or equal to b, then we should return false. If it's less than b, then it should be returned true, and return len a greater than len b. Okay, this I think is false, right? Because len b greater than len a should be true, because let me tell. So len a, if length of a is less than length of b, then length of a is obviously the smaller one, right? So if length of a is less than length of b, then this should return to true. So yeah, so that's done. So now coming to the order, I think it's okay this one, and I think even this one's fine. So I guess it should run. Let's see. Hopefully no compiling mistakes this time. Okay, so the first one is as expected. Now let's test the second and third one. So true, false, false. Okay, so yeah, so let's try to submit this question. Okay, output is false. We expected truth, and we uh, okay. So the equal to case should also be considered. So I think that's the mistake we made. Let's try it out. Okay, I think that's the mistake we made. Let's see if it happens again. Okay, fine. Yay. Good, good, good. Okay, that's enough, right? See, the thing is, I don't want to do these kind of questions, but just by luck they keep coming up. So, since I'm recording, I'll explain it again. So, this may be familiar question to most of you, but here I go. So basically, it's asking the right side view, right? Let's imagine tree as a 2D structure, and you're standing to the right side of it. You look your left side, and whatever numbers you see on the outermost side, those numbers you have to record. For example, here 134, right? So the approach will pretty much go like this. Okay. So find height, and then declare a vector of size height. Keep iterating to right and then left. So this order is quite important because you see, I don't know how I can draw this, but let's say there is an extension here 5 extended here, 5 has also extension of 7 here, and also extension of 4, let's say 10 here. Now when we come like this from 5, we have to go to 10, because if it's right side view and we have an element that's on the same height level as the other element, then we should go to the rightmost element first. So we always go to right and then left. Okay, that makes sense. And so one advantage which we get from doing this kind of uh, travel is, if there is a node at that height, then we always reach the rightmost node first, and then the leftmost node. Sorry, and then the other one. So we always reach the rightmost node first. So um, okay, I'll try to show you how to find the height of the node first. If root is equal to null, so basically if I pass null, it should be 0, right? And then return. So what I'll do is like the parent node is considered as 1, and then the left side node, let's say a, and the right side node height is b, considering the left side node is the height and the right side node is the height, individual heights. So now we have to return the greater of 1 plus a or 1 plus b. So that's exactly what I'm doing here. Root dot left, comma, hei of root dot right. So hopefully this comes out okay. And then what we should do is like void and correct. So tree node star root. So what this kind of does is, okay, vector int answer Yeah, in the last question I said, right, this ampersand sign. So now this, in this case, it's really important because, okay, let me explain while I'll explain while the recursion step comes up. So end current height. So let me just put curve fruit equal to null. Now return. Now if so, so first we have to go to right, but let's just say mm, he needed integers, right? No, okay, he needed integers. So let's just fill them with the kids minus 100. So let's just put uh, just 1 minute. I have to check my phone for a bit. Okay, sorry for that. So fruit equal to null. So okay, let's just wrap it up real quick. Uh, So initial I'll put initialize all the values in the height h with minus 101. So that way I know that I haven't filled that position yet. So now I will fill that position. Did not well. Uh, so now we have to go to root dot right first. Same as answer, and the current position will increase. Root dot left answer, and the current position will also increase. Sure. And h is equal to ha dot root vector int let's just say answer minus 101. Sorry, I'm going a little fast because I've got some important message, so I'll just complete it and leave. So correct of root, and then answer, and then current is obviously 0, so return answer. So hopefully this should run. Okay, it's 134. Okay, this seems all right. 1 3 and empty. It's 1 3 and empty. So option 2 is given to if h2 contains a permutation of h1 or false otherwise. Okay, I don't understand what exactly this means, but moving on. Okay, so we need to check all the permutations. Can we check all the permutations? Okay, I don't think so. This is basically the anagram question, I guess, right? You know, so what we can do is like, so I'll just be quick and explain the approach first. So let's just say I have got ABCD, right? So I also get DACD and DAACB. So all these are same, right? So what I'll do is like I'll define a vector of size 26 and I'll store the counts. Okay, let me write it in English. Store the count of alphabets in the vector and use a map to map the vector. So use a map. Can we use a map? Okay, we don't need a map actually. So create a vector for the sliding window. If at any position the two vectors are equal, then return true. Okay, seems about right. Um, so one thing we did not consider is uh, S2 contains a permutation of S1, right? So S1 should always be less than or equal to S2 in terms of size. So that's we can add a check in the first line itself. Let's just declare ALU since we are going to be out of time, and v is equal to h2 dot length. Now okay, so for int okay, let's just go with the vector. So this is my original vector. Correct. This will contain the counts of h2. Okay, let's just add if a is greater than b. So that means the size of s1 is obviously greater than s2. Then we should always return false. And then I is equal to 0, I less than b, I plus plus. So s2 contains a permutation of s1, right? So b always greater than a. Sorry, my bad. Sorry. Which way this is good? So it's two content. So correct dot s1 dot I minus a plus plus. So once we got the count vector, we also need to create the parallel vector. So compare. Actually, let's make it count. You know, when why crick always. Okay, let's keep it quick. Crick. No, I always crick. Crick dot. Sorry, that's why you should not use crick always. But here we go. S2 dot I minus a plus plus. Here we go. So what we should do is like for int I is equal to, so except the last comparison, every other comparison we should be able to do. So we should move from I less than I plus plus. If equal to compare, return true, and compare should be updated. So s2 dot I minus a b plus plus compare dot s2 dot I minus a. So this is not I, this is I minus b. Yeah. So what we are doing is assume a big word and you have got a small word size of 2, but you keep the move. Let's say here first we consider ei, right? Then we add d, so it becomes eid. So up until step number 21 it becomes eid. From after step number 22 it only becomes id. Okay, so if that's clear, we can move on. And then return. So one thing here you can note is like uh, you can't compare the last one. Let's say this OO, this case won't be considered, so we use the last step as that one. So if the last step is correct, then we'll return true. If the last step is also wrong, then it would be return false. So hopefully this should run. I don't understand. Okay, vector spelling is wrong, I guess. Oh god, these many mistakes. Okay, I should be more careful while coding. That's definitely an observation. Okay, it's random error. So generally random error comes when we access something which we are not supposed to. So let's just see if S2 is a permutation of S1. So obviously this one and this one and this one, this one. Okay, let's just hope this works. Oh man. So okay, I think we're making a logical mistake somewhere. Let's just check it. So length of A, length of B, that's cool. So if A greater than B, then we should return false. That's also fine. So we have to keep this A, right? Don't know what I was doing. So this is compare. S2 contains a permutation of S1. So S1 must be in cook and S2 must be in compare. So that's great. So that's great. Is equal to length if I greater than B. Okay. I just don't understand where the problem is coming. So S1 length is A, right? So definitely up until here there is no problem. And S2 length is, so since A is less than or equal to B, then there should not be a problem since S2 length is B. So I is equal to don't quite understand where the problem is. Maybe this one, I guess. So okay, this should be here S2. Okay, I think I got it. Done. This should be done. Cool. False. Hopefully will be done. Nice. So let's just check the score. Hopefully some 40% maybe. 40% is the sweet spot for me. So let's just wait. Sorry, I rushed out a little bit because I have something important now. My friend just called, so I have to go. Come on, man, come on. Okay, that's actually pretty good. So that's it, guys. Thank you for this video.